Hey everyone, so today I will be telling you about Newton's laws of motion. Now, you can do this the two ways. One is just clicking on the video, which I will put on the description, and just listen to the video. Or the second way, which is slightly better, you listen to the video, but at the same time you complete the text that is right here by listening to the words of the video. And this would mean that you would memorize the information and understand the information a little bit better, okay? So, click on that video and try to answer the questions or fill in the gaps in the text that I have in here. And I'm going to move to the next slide where I'm going to give you the answers. So, if you don't want to check the answers or if you don't want to see if the answers are correct right now, or if you want to try them first, then freeze the video or pause the video, okay? So, Isaac Newton developed three laws of motion. The first law, also known as the law of inertia, states that an object will remain at rest or that is supposed to say or, in a uniform motion unless is acted upon an unbalanced force. Meaning, if the forces are balanced, the motion of the object remains the same. So inertia is the object's tendency to remain at rest or in a constant motion. The second law relates force, mass, and acceleration. And the formula that shows this law is force equals mass times acceleration. And then the Newton's third law is the law of action-reaction. And it says that for every action there is an equal and opposite reaction, okay? So the first law, I have some demos for all of them, but the first law is, for example, when you have, for example, I think I have that part on the picture. So something, imagine that, for example, in the Harry Potter movie, the guy stops the bus really quickly and then Harry Potter goes against the window of the movie. This is in the Prisoner of Azkaban. So this shows the law of inertia. Harry was still on the bus, but because he couldn't stop, because he was not being acted upon an unbalanced force, only the bus was, he continued in his uniform motion, which was moving forward, okay? And then he finally stopped when he was acted upon an unbalanced force, which was the window. The law of force, mass, and acceleration. That law, I'm gonna make a video just about that law or giving you more examples of that law. So don't worry about it too much. Just know that force equals mass times acceleration. So the larger the mass, the more force you need to do or to apply for that mass to accelerate to a certain number. Or then the larger the mass, the less acceleration it will have for the same amount of force. And then the last law of Newton is kind of, I like to call it like the karma. So it's the action-reaction. So everything that a force does, there is going to be a force balancing out to that one, so counter-reacting that one. And this is how, for example, rockets go up to space, okay? So you get the action. The gas is being sent down towards the ground at a very high speeds, and the reaction is the force from the ground on the rocket, which makes it go up, okay? What I say to the students is, imagine you slap someone, the person certainly feels the slap, but they are also going to feel, or you are going to feel the slap in your hand, because your hand is going to feel hot, or at least it hurts a little bit, okay? So that's the law of Newton's action-reaction. And in case you want to demonstrate these laws, the air track is a great example of Newton's laws of motion for the first one. So for the inertia one, where I already have a video telling you a little bit about the air track, so you can reduce friction as much as possible to make the forces to be balanced, and you will see that the actual trolley is going to keep moving around so as if there was no force counteracting it, and then the moment that you turn the air track off, friction kicks in, so the trolley is acted upon by an unbalanced force and the trolley stops. The second law can be easily seen with the use of trolley and masses, where the trolley is simply being accelerated, the mass of the trolley is being accelerated only due to the force that you add up on the string that is hooked to the trolley, and you add more masses and you will see that the trolley, using a light gauge if you can, moves faster and faster the more force you apply for the same mass of the trolley. You can also remain the force the same and increase the masses on the trolley, and this will increase the mass of the trolley, and again you can see force equals mass times acceleration. And for Newton's third law, you can use a balloon. So you get a balloon filled with air, and then you release the balloon or the air, and the action will be the air rushing downwards, and then the reaction will be the balloon forced upwards. The balloon tends to go in a circulatory motion, or in some random motion, but this is because of the vortex of the shape of the balloon, okay? So yeah, that is it. Next lesson will be force and acceleration. I hope it made sense. Up to my next video. Be happy and healthy. Bye!